The next program that we write is a new type of program again, and this program is basically going to input us with two numbers m and n. Now what we are going to do is we are going to do compute 1 to the power of m plus 2 to the power of m plus 3 to the power of m plus 4 to the power of m plus 5 to the power of m, and so on. You can understand, dot 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 up to what? All of you have understood by now, n to the power of m. So this is what I need to compute and output. So say suppose my input was m and n, instead of that I write 5 and 4. Then my output will be 1 to the power of what? M, that is 5, plus 2 to the power of 5, how long? Plus 3 to the power of 5, plus how long? 4 to the power of 5, and that's it. Because this n is 4 and I need to go up to n to the power of m, so 4 to the power of 5 maximum. Similarly, you can understand if it is 2 and 3, then definitely it is, I need to compute 1 square plus 2 square plus how much? 3 square, and that's it, not more than that. So I need to compute only this much, which means that 1 square plus 2 square plus 3 square, and that is it, because I need to go up to n only. So n is 3 over here, so definitely 1 square plus 2 square plus 3 square. So this is what you need to compute. So let me comment out this portion. This is not a part of the program. Let me comment out this portion. Now I will be writing this program. So you tell me how to do it. Simple. See, let me declare the variables first. Let me complete that portion. Int, I need an m, I need an n, and all these things. Definitely I will need a sum to keep the sum. Let me see what more variables we need in latter stages while writing the program. See, we have to do one thing here. This has to be considered as I. I think all of you will understand that. This will be considered as I. So I is initially 1, next time I should be 2, next time I should be 3, next time I should be 4, next time I should be 5, and so on. I should be continuing up to n, which means there must be a loop where I should start from 1 and continue until I is less than equal to n with increment of I. Please notice this. I should increase gradually from 1, then 2, then 3 up to n. That is, I should iterate from 1 to n. So I have just written this for loop where I am making I iterating from 1 to n. Now within this for loop, what do I need to do? I need to compute 1 to the power of m firstly, secondly 2 to the power of m, next 3 to the power of m, next 4 to the power of m. So don't you understand, within this for loop I need to compute I to the power of m. When I entering with I equal to 1, I need to compute 1 to the power of m. When I am entering with I equal to 2, I need to compute 2 to the power of m. So here I should have a program which will compute I to the power of m. If you understand this, I need to compute I to the power of m. I comment this one out. This is for understanding only. I just need to compute I to the power of m. How to compute that? You know, for that I need another for loop where, because I has to be multiplied m times, I to the power of m, what does it mean? I to the power of m basically means a product variable where I into I into I into I and so on continues. How many times? I to the power of m. So m times. This is what I to the power of m means. I need to compute a product of I into I into I into I and so on, maybe m times, which means I need a for loop over here which will compute this product equal to I into I into I m times for me. So what can be that for loop? For that I will need another variable j to start from 1 again and continue up to m just as a counter. J is nothing but a counter which will count from 1 to m, and every time in the loop I need to multiply I with product. So product is equal to product into I. I think you understand this. Every time what I am doing, I am multiplying I with product. I need this I to be multiplied to product every time, and product must be initialized to 1. So don't you understand? Here I need another initialization, product equal to 1. So I enter the first loop firstly with product equal to 1. But every time this product equal to 1 will not be initialized because the initialization happens only the first time. So it enters with product equal to 1. But every time in the loop, this I is getting multiplied with product. That is, I will be multiplied with product how many times? Definitely m times, because this loop is iterating from j equal to 1 to j less than equal to m. So I think you understand this. So you have got this product now. Just let me put a gap to not to look too untidy. Okay. So this is how you know you have got the product with you. But another thing you need to understand now, this product you have got, what is that product? That is I to the power of m. So when it enters the for loop the first time, this is 1 to the, this product computes 1 to the power of m and goes out of the for loop, inner for loop. When it enters the outer for loop second time with I equal to 2, this inner for loop computes 2 to the power of m and goes out of the inner for loop. Again it goes to the outer for loop with I equal to 3, and that inner for loop computes 3 to the power of m and goes out. So every time this 1 to the power of m, 2 to the power of m, 3 to the power of m has to be added with one another. So don't you understand that we need a sum variable where every time this output product needs to be added. Don't you forget, when it goes to the outer for loop, goes back to the outer for loop with the next value of I, you are again initializing the product equal to 1 before entering the inner for loop. But sum equal to sum plus product is needed, because every time you are coming out of it, 1 to the power of m, 2 to the power of m, 3 to the power of m, every time this I to the power of m has to be added to sum to get the final sum. But don't you forget that this sum has to be initialized to 0. So you can initialize the sum to 0 over here, because when it enters the outer for loop, it should enter with sum equal to 0 every time the product computed in the inner for loop, and this product has to be added to this sum which was initialized to 0. So every time the product added, there is 1 to the power of m added, 2 to the power of m added, 3 to the power of m added, and so on. Sum will finally contain 1 to the power of m plus 2 to the power of m plus 3 to the power of m plus 4 to the power of m. How long? Up to n to the power of m, because you are making I move up to n. So last time it enters the for loop with I equal to n. So last time this computes what? N to the power of m, which will also be added to sum. So this is itself the program. Out of this program for loop, outer for loop, you need to just write a printf. The required sum is %d, and what that %d will be replaced by? With the variable sum. So this thing is done now. You just execute this program, but don't forget, before executing, I have used so many variables. I have used I have used j. So let us initialize those. I have taken m, n, sum, don't forget product, I, j, all these variables need to be declared. So I have done that. I feel I have declared everything now. Let me execute this program, but before executing, I have not inputted the values of m and n from the user. Please don't forget that. Printf enter m and n. Okay, so I need to scan the m and n. Scanf %d ampersand m ampersand n. I need to scan this. Let me execute this program now. So alt R, enter, 0 errors. Maybe I start with a very simple one, maybe 3, that is 1 cube plus 2 cube plus 3 cube and so on. 1 cube plus 2 cube plus 3 cube plus 4 cube plus 5 cube and so on. So how long? Maybe up to 4 cube. Maybe up to 4 cube, that is 1 cube plus 2 cube plus 3 cube plus 4 cube, let me say 100. See, 1 cube is 1, 2 cube is 8, 4 cube is 3 cube is what is that, 27, and 4 cube is how much, 64. I repeat, 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64. So 1 plus 8, 9, 9 plus 27, 36, 36 plus 64 is 100, required sum is 100. Try out with another example, maybe 2 and 3, that is 1 square plus 2 square plus 3 square. 14, 1 square is 1, 2 square is 4, 3 square is 9, so 1 plus 4 plus 9 makes it 5 plus 9, 14 itself. So let me reverse this, maybe 3 and 2, what is this, 1 cube plus 2 cube, 9 definitely, 1 cube is 1, 2 cube is 8, 1 plus 8 is 9. You can try out with bigger numbers, maybe 4 and 5, that is 1 to the power of 4 plus 2 to the power of 4 plus 3 to the power of 4 plus 4 to the power of 4 plus 5 to the power of 4. It is 979. You can check it out yourself. Okay, so this program is compute this thing. You have understood a very interesting thing throughout this process for the last 2-3 programs, which is nested for loop. One for loop within another for loop. Let us take a bit of rest and come back over here. Thank you so much.